Hello everyone, welcome to our PVM group. I am Sarika Baviskar and today I will discuss on important topic that are polygons. In mathematics, polygons are important and basic definitions, important things related to polygons, classification, all these things today I will discuss with you. Firstly, see the definition of polygon. A polygon is a closed figure made by joining the line segments where each line segment intersect exactly 2 points of the others. Now here three important criteria are there. First one, the figure must be a closed figure. Second one, it is made up of line segments. And third one, each line segment intersect exactly 2 points. If all three criteria are satisfied, then you can say that figures are the polygons. Now see the figures. In these figures, all these figures are closed figure and made up of line segments. And if you check the intersecting point of each and every segment, each and every side of a figure, every side of the figure intersect exactly in 2 points, means we can say that all these are the polygons. Now see the figure. Again check the criteria. Is it a polygon? See, it is a closed figure. It is made up of line segment. Every side of the line segment intersect at 2 points and therefore you can say that it is a closed figure. Now, is it a polygon? It is a closed figure made up of line segment, but it is not a polygon. Now find out the reason why it is not a polygon. Now see here, intersecting points. Check the third criteria, 1, 2 and 3. Total 3 intersecting points are there. Similarly, in the other side, 1, 2, 3. 3 intersecting points are given for this figure and that's why it is not a polygon. See next figures. These are closed figure, but see this side for this figure and this one for the other figure, that are the curves. These are not the line segments. All three are the curves and that's why it is not made up of line segment, and that's why these two figures are not the polygons. In this way you can check the criteria for polygon and decide it is a polygon or not. Now types of polygons. First type, regular polygon. Polygons which are equiangular and equilateral are called as regular polygons. Now here see the word equiangular and equilateral. What is the meaning of these two words? Equiangular means measure of each angle is same. Equilateral means length of all sides of any polygons are equal. Then you can say that polygon is a regular polygon. Next one, irregular polygon. If the polygon is not regular, then you can say that it is a irregular polygon. Now in irregular polygon, a measure of angles are different and length of sides are also different. Check the figures. See the table. Here this triangle. It is a equilateral triangle. All three sides are equal. Measure of each angle. We know that in measure of each angle of an equilateral triangle is 60 degree, and that's why you can say that it is equiangular and equilateral, and it is a regular figure. Square. All four sides are equal. Measure of each angle is 90 degree. Equiangular and equilateral. It is a regular figure. Pentagon. All five sides are equal, and when sides are equal, angles are also equal. It is a regular pentagon and it is a regular hexagon. But these figures, in these figures, length of sides are different, measure of angles are different, acute angle, obtuse angle, this type of angles are present here, and that's why these figures are not regular figure. These are the irregular figures. Next one, convex polygons. If every line segment drawn between any 2 points inside the figure or on the figure, and that line segment lies in the interior part of the figure, means if we consider any 2 point, that point lies on the figure or inside the figure, and if you join both the points, the line segment form entirely in the interior part of the figure, then you can say that it is a convex polygon. For concave polygon, same condition we consider here. Take any 2 points on the figure or inside the figure, join them. That line segment entirely does not lies in the interior part of the side, some part of that segment in the exterior part, then you can say that it is a concave polygon. Now see the figures. In this figure, if you consider here 2 points and join these two, from here we consider the point and join, just a minute, draw the line. Now this line, these are the 2 points and this line lies entirely in the figure. Consider any 2 points. Here we consider 1 point and on this line we consider the point, and if you join that segment, it lies in the interior part of the figure, means it is a convex polygon. See the second figure. In the second figure, here we consider 1 point and join to the other point. Now this segment. In this segment, this part, see here, this part of the segment is in the exterior side, in the exterior part of this figure. It is not in the interior parts. That's why you can say that it is a concave polygon. In the simple language, you can say if you join the diagonal, if you draw the diagonal and some part of the diagonal is outside the figure, then you can say that it is a concave. And if whole diagonal lies inside the figure, in the interior part of the figure, then it is a convex figure. In the other word, you can use this criteria also. Now see, again two figures are given. In this figure, if you try to join the figures, to join any points and draw the figure segment, that segment lies inside. In this figure, if you consider here 2 points and join them, then some part of that line segment is outside the figure. It is a concave figure. Now some figures are given. You have to just identify these figures are regular polygons or not. See first one. It is a equilateral triangle, and you know that in equilateral triangle, angles and sides are equal. It is a regular figure. Rhombus. All four sides are equal, but measure of angles are not same, and that's why it is not a regular figure. Hexagon. This side of the figure is long, other sides are short, means length of sides are different, and that's why it is not a regular figure. Square, all four sides are equal, angles are equal, it is regular figure. Right angle triangle. Measure of one angle is 90 degree, remaining two angles are less than 90. Angles are not equal, sides are also different, and that's why it is irregular figure. See the trapezium, it is also a irregular figure. Now see next part, diagonals of the polygons. What is the diagonal of polygon? A diagonal of a polygon is a line segment joining non-consecutive points of a polygon. Now here non-consecutive points. What is the meaning of non-consecutive point? See the figure. Now here if you consider this point, then these 2 points are consecutive points, means nearer to that points, and remaining these 2 points are non-consecutive points. And if you join the line segment from here to here, see here, if you join this line segment and this line segment which join the non-consecutive point of that point, these are the diagonal. These line segments are the diagonal for this figure. Now if you consider the other point, see here, if you consider this point, then for this point these two are consecutive and the opposite, these two are non-consecutive points. Then if you draw the segment from here to here, it is a diagonal. If you draw this segment, it is a diagonal, means line segment joining non-consecutive points of the vertex is called as a diagonal. To find the number of diagonals, how many diagonals are there for any polygon, to find that one relation is given, n into n minus 3 upon 2, where n represents number of sides. Now see here, pentagon is given, 5 sides are given, and if you substitute here n is equals to 5, you will get 5 minus 2, that value will be, sorry, 5 minus 3, that value will be 2. Okay, and these two get cancelled in numerator and denominator. Now what is remaining? Only this n is remaining, and value of this n is 5. Number of sides means number of diagonals for this figure is 5. 5 diagonals are present here. Now here, if you consider triangle, for triangle, if you consider this point, then both the points are consecutive points for a triangle, means there are no consecutive points for a triangle, and that's why segment joining non-consecutive point, it is not available, and number of diagonals becomes 0 there. Substitute here value, n is equals to 3. For a triangle, n is equals to 3. 3 minus 3 becomes 0. 0 multiplied by 3, it becomes 0, and number of diagonals for triangles are 0. Okay, in this way you can find out number of diagonals for pentagon, hexagon. For every polygon, use this formula, substitute the value of number of sides, you can find out the number of diagonals for each and every figure. Now classification of polygons according to their sides. If you, in polygons, in the definition of polygons, it is given that it is a closed figure, and to make a closed figure we need minimum 3 sides, and that's why classification of polygons starts from 3-sided polygons, which is called as a triangle. 3-sided polygons are triangles. See the different triangles. 4-sided polygons, that are called as the quadrilaterals. All these are the 4-sided polygons. 5-sided polygons, that are called as pentagons. See here, this pentagon is a regular pentagon and it is a irregular pentagon. 6-sided polygons, that are called as hexagons. Regular hexagon and irregular hexagon. 7-sided polygons, that are called as heptagons, and 8-sided polygons, that are called as octagons. 9-sided polygons, nanogons, and lastly 10-sided polygons, that are called as decagons. See the figure. And in this way classification of polygons is given. Up to 10 sides names are given. 11, 12-sided polygons are also available, but up to 10 names, specific names are given in this video. Now next important conditions for polygons: sum of the measures of interior angles. Sum of measure of interior angles of a triangle, it is known. For quadrilateral it is known, but more than 4 sides are given. At that time, how to find the sum of interior angles, and for that relation is given n minus 2 into 180 degree. Again here n represents number of sides of the polygons. Now if you consider 6-sided polygon, means hexagon, means value of n is 6 here. Substitute 6 minus 2, that becomes 4, and 4 multiplied by 180, that value will be 720, means sum of interior angles for hexagon is 720. In this way you can find out sum of interior angles of heptagon, decagon or octagon also. Next, exterior angles. If you consider sum of exterior angles, then for every polygon sum of exterior angle remains same, and that value is fixed, that is 360 degree. The sum of exterior angles of any polygon is always 360 degree. Sum of interior angles changes according to their number of sides. If the number of sides increases, sum of interior angles is also increases, but in sum of exterior angles the value is fixed, and that value is 360 degree. Now in our day-to-day life we observe the different figures, different polygonal figures, some conical figures, that figures are applicable in our day-to-day life. One small clip is given for that, just observe this. Everything about polygons I had explained in this video, and I hope so you understand all these things which are given by me. And thank you for watching this video.